welcome viewers. Today we are in the final segment of ADC, and in today's lecture we will cover the characteristics and specifications of ADC. ADC has certain characteristics and specifications that distinguishes it from a DAC. ADCs are used in digital voltmeters due to its good conversion accuracy and low cost. The disadvantage of a dual slope ADC is its slow speed. Dual slope AD converter. A dual slope AD converter has 4 major blocks: an integrator, a comparator, a binary counter, and a switch driver. The conversion process occurs when T is equal to 0, where S1 is in position 0, thus connecting the analog voltage VA to the input of the integrator. The integrator thus generates the output. This results in a high VC, enabling the AND gate and clock pulses reach the n-bit binary counter that was initially clear. Now the counter counts from 0000 to 11111 when a 2 to the power n minus 1 clock pulse are applied. In the next clock pulse, the counter is cleared and Q becomes 1, which controls the state of S1, which now moves at the position 1 at T is equal to 1, thus connecting minus VR to the input of the integrator. The integrator output now becomes the integrator now moves in the positive direction. The counter counts until V0 is less than 0. Now when V0 goes positive at T is equal to 2, Vc will go low, disabling the AND gate. The counter thus stops counting at the absence of clock pulses. The waveform of dual slope AD converter is given as the time T1 is given by, here Tc is the time period of the clock pulses. We know the integrator output voltage at V0 is given by, therefore, for the count recorded at the counter Bn at T2 is AD converter using voltage to frequency conversion. An analog voltage can be converted to digital form by producing pulses where the frequency is proportional to the analog voltage. The analog voltage is applied to the integrator whose output is applied in the inverting input terminal of a comparator. The non-inverting input terminal of the comparator is connected to the reference voltage minus VR. Initially, when switch S is open, the voltage V0 will decrease linearly with time, as shown in the figure. When a decreasing V0 reaches minus VR, then the comparator output Vc goes high. To close the switch S, this applied to the integrator through a monostable multivibrator. When switch is closed, then the capacitor discharges and the V0 reaches 0, and the procedure continues so on. For the pulse width of monostable multivibrator BTD, therefore the switch remains closed, but once opened, V0 starts decreasing again. Let us consider that T is very much greater than Td. The frequency of the waveform V0 and Vc is given by, the following expression is given as the voltage frequency converter is shown where the output of the VF converter is applied to the clock input of the counter through the AND gate. The AND gate is enabled for a fixed interval T1. The reading of the counter T is equal to T1 is given as AD converter using voltage time conversion. In an ADC using voltage frequency converter, the cycles of the variables frequency sources are counted for fixed time period. In this diagram, a negative reference voltage minus VR is applied to the inverting input terminal of the comparator. The non-inverting terminal is connected to VA or analog voltage. The output of the comparator remains at logic 1 as long as the output of the integrator V0 is less than VA. When V0 crosses VA at t is equal to capital T, Vc goes low. The AND gate is enabled when Vn is low and S remains open. When Vn goes high, the switch S is closed, discharging then capacitor and disabling the AND gate. The time t is given by, thus shows that t is proportional to Va. The counter reading n at t is equal to t is given by specification of ADC. The following specifications are specified by manufacturers that distinguishes an ADC from a DAC, which are range of input voltage, input impedance, accuracy, conversion time and format of digital output. In today's lecture, we have learned dual slope AD converter using voltage to frequency conversion, AD converter using voltage time conversion, specification of ADC. With this, we are at the end of this lecture. We will meet again in the next lecture. Till then, learn and practice. Thank you and goodbye.